What's up, guys? Today we're going to learn how to add and subtract values that are in scientific notation. Alright, here it is. Okay, so quick recap. A number is said to be written in scientific notation if there is a single non-zero digit to the left of the decimal, and then that number is multiplied by some power of 10. And so when you are asked to add or subtract values that are both in scientific notation, there's two ways to do it, and I'm going to show both of them here. So the first way is to just rewrite both of them in standard form and then just add and subtract like you normally would. So for example, I'm gonna rewrite this top number here in standard form. So since I'm multiplying 5.78 by 10 to the 5th, that means I'm multiplying this by 10 5 times, which means I'm gonna move the decimal 5 times to the right. Okay, so if I were to do 1, 2, 3, 4, 5, then I would have 3 zeros on the end of this 578 here. So I have 578,000. And then here, when I convert this number to standard form, I'm going to have a 169,000. And then I'm just going to go ahead and add them like I normally would. Okay, and now if I want to put this back into scientific notation, then again, I'm only allowed one non-zero digit to the left of the decimal, so I'm going to have to put my decimal there. So that's going to be 7.47. And then to get my decimal to move to where it belongs, which is the end, I would have to move it 1, 2, 3, 4, 5 times. So I have times 10 to the 5th. And what we see here is that if our powers of 10 match between the two numbers, then all we have to do is add up the decimal portion of the scientific notation and then just keep our power of 10. So what I mean by that is I can just ignore, as long as the power of 10 matches, I can ignore that and then just add the 5.78 and the 1.69 and get the 7.47, and then just keep my times 10 to the 5th. And so that illustrates the sort of the second way that this can be done is if I don't feel like writing this out in the standard form, then I can get my powers of 10 to match and then go ahead and add what's left. So let's go ahead and do that. So instead of writing these in standard form, I'm going to think, well, how can I get my exponents to match here? I could either make my 7 an 8, or I can make my 8 a 7. So I'll go ahead and turn the 8 into a 7. So in order to do that, that means I would be dividing this by 10 to get that exponent to reduce by 1. And since I'm dividing by 10, I have to make up for it by multiplying by 10 over here, which means I'm going to move my decimal to the right once. So this is going to look like this. Okay. So I'll say that again. Since I reduced my exponent by 1, that means I divided by 10. And to make up for it, I had to multiply by 10. So I moved my decimal to the right once. So 0.32 times 10 to the 8th is the same as 3.2 times 10 to the 7th. And now what I'll do is I'll keep this top one, so I'll rewrite that. Okay, and now, since my powers of 10 match, I can just go ahead and add the decimal portion. So I'll do that off on the side here. Remember, when you're adding, you want to keep your decimals in line. And then I'll fill in the extra space with a 0. And then go ahead and add. Okay, so I have 12.43 times 10 to the 7th, right? I keep my power of 10. And now you just have to be careful because this is not in scientific notation. Remember, you're only allowed one non-zero digit to the left of the decimal, so we can easily convert this to scientific notation. And to do that, again, since we were only allowed one digit, we'd have to move the decimal to the left once, which is dividing by 10. Okay, so I'm going to move my decimal to the left once. And then since I divided by 10, I have to make up for it by multiplying by 10. So I'm going to increase my exponent by 1. Okay. And now we'll do a subtraction one here. So the same rule applies here. I can get my power of 10 to match, and then just go ahead and subtract these values, the decimal portion of the value here. Now, it is worth mentioning that these exponents are small enough that it's probably worth it to just go ahead and write these in standard form and subtract. But just to practice the trick here, we'll go ahead and I reduced the decimal last time, so this time I'll bump this up to a 4. So since I want to make this 10 to the 4th, that means I'm multiplying by 10, which means I'd have to divide this by 10, which means I'd have to move the decimal to the left. Okay, and I'll copy this one down. Okay, and now since my powers of 10 match, I can just go ahead and subtract these values, which I'll do off on the side here. Okay, remember you want to line up your decimal. And then I'll fill in with a 0 here. Okay, take from the 7. Gotta take from the 3. Then we gotta take from the 7 again. Keep the decimal where it is. And then we have 6.682 times 10 to the 4th. And then you just want to make sure that this is in scientific notation, which it is, so we don't have to make any conversions there. All right, and with that said, guys, it's been demonstrated.